Okay, do we need to do Chapter 3? Yes. Chapter 3, Subnetting and VLSM and Troubleshooting. The subnetting and troubleshooting we've already done. VLSM is the only thing I'm going to spend on. I'll go through the slides. But VLSM is the only thing. Variable link subnet mask. What we did in networking 2 is called CIDR, Classless Internet Domain Routing. And all of the subnets were the same size. VLSM, they don't all have to be the same size. Not a big deal.
This still is that wildcard you're talking
It's
about,
the same. No. Wildcard mask is different.
Okay.
We're going to get to wildcard mask when we do access control list.
Okay.
Now, this is subnets, but what we say is we want a subnet with 120 hosts, one with 25 hosts, one with 2 hosts. Not a big deal. Going to show you the process. The trick is to start with the biggest one, take that block of addresses out, go to the next available network address, take the next largest block, and the next largest block until you get all the way through the numbers that you need. So variable link subnet mask. It's kind of like, and subnetting is kind of like getting change for a 10 or change for a 20. You got a $10 bill and you want change for it. If somebody gave you 10 ones, that would be CIDR. All of the things that you broke it into would be dollar bills.
And then you want quarters.
You'd still have, we're going to get there, you'd still have the same number of pennies or cents in a $10 bill. You'd have $10. If we wanted to break it up, somebody might give you a $5 bill and 4 ones and 4 quarters. That's what VLSM is. That's all it is. Breaking it up into not equal size blocks.
Subnetting within subnetting.
Subnetting within, it's kind of subnetting within subnetting. That may be a way to think about it. But VLSM, Variable Link Subnet Mask, it is a way to preserve addresses. And one of the things that we're going to say right now with Cisco, now back in networking, you couldn't use the 0 network and you couldn't use the broadcast network, right? Okay, in Cisco, if we give the router a command IP subnet 0, we can use subnet 0. And we can use the broadcast subnet, so you don't lose anything. Windows doesn't do that. It can do that, but it doesn't do that. So in Cisco, the IP subnet 0 and all the new, I think all the new iOSs have that in it automatically. I went to, a few years ago, a presentation that they were given because they were doing it in this part of the state. So the people from Virginia Beach, it was during one of those money crunch times, they sent me there to take notes. I went to take notes, and they did a lab. And we were putting in an IP address on subnet 0. Worked on one router and wouldn't work on the other router because one of them had a different iOS version than the other one. The one that had been updated automatically put IP subnet 0 in it. The one it didn't work on didn't. If it doesn't work, when we get to the configurations next week, start talking about those, look at the configuration, see if it's got the IP subnet 0 command. If it doesn't, just put it in. And that's all it is. Subnetting basics, how to create subnets, subnet masks, and CIDR Class C, B. We'll look at these things briefly. The thing that I want to spend some time on, VLSM has got a lot of pictures, but it really is just subnetting that you already know how to do, except everything's going to have a different size subnet mask. Nothing magic about it. And we're not going to lose anything because we can now use subnet 0. So we can start with the 0 subnet and use everything. Okay, so the benefits of subnetting, we reduce network traffic back to the broadcast. We want to break it down. And I've told you some of the reasons that we did it here. Broadcast, one of those things to keep people from going other places, some other things. Optimized performance, simplified management. Once you get it set up, simplified management. Maybe not so simplified as you're initially getting the thing configured. Facilitated spanning of large geographical distances. One of the things it does is conserves addresses because when we put 2 routers together, we need a grand total of 2 addresses. So the smallest network that you're going to be assigned is a Class C network that you can buy. So you're going to buy 254 usable addresses to use 2 of them. These things are not free. Public addresses are not free.
I thought they weren't.
You thought they were? Well, they're not. So you'll want to conserve your addresses. The powers of 2, I think I skipped one, didn't I? How did I do that? Where'd my mouse go? It left me. I ought to get back to something. It says the step-by-step. How do you figure out what you want to do with subnetting? So determine the required number of network IDs. What I think would more properly go in here is you either got to know how many hosts you need per network or how many networks you need. You can go either direction. And on testing, what you'll usually say is, no, so many subnets with at least so many hosts per subnet. They're always going to balance. We can't create addresses by subnetting. They're always going to have to be that number. The number of required host IDs per subnet, and this is the first, it says required network IDs, and then the required hosts per subnet. You've got to know one or the other. And you don't have to know necessarily the number of subnets to start with. You may need the number of hosts. If we need 120 hosts, then we know how many host bits we need. And that's kind of where the variable length comes in. Based on the above, create the following. 1 subnet mask for your entire network, a unique subnet ID for each physical segment. The reason that we need to know about the class full addresses is that's the starting point for subnetting. If the address is a class C, we put in the class full subnet, and then the subnet ID, as we break it down, goes from there. The powers of 2, and this is something that probably is handy to write down at some point in time, because how many of what do I need? If I have 2 bits, 2 to the 1th, or excuse me, if I have 1 bit, 2 to the 1th is 2. It's a 0 or a 1, that's it. 2 bits, 4, 3, 8. So again, that's handy, particularly, I think, unless you can do it really quick on your fingers, if you're going to do a test, certification test or whatever, make that table when you start up. When you do these tests, particularly in Cisco, I think it's like 15 minutes to show you how to do the test. Well, that gives you some time. It's available. You don't have to use it all. That gives you some time to put the things that you want onto the scratch paper that you have, the little erasable sheet that you have. So use that time to make yourself notes. Subnet masks. What does a subnet mask do? What does it define? Which part's the host? Which part's the network? The 1s are the network portion. The 0s are the host portion. So that's the only thing it does for us is tell us how many bits are in the network address and how many bits are in the host address. The Class A's, we just had those, but network, node, and node, host, all sorts of different terms. Node address, host address, whatever else is an assignable address, which means it's not the network address and it's not the broadcast address, since we can now use the network, the 0 subnet and the broadcast subnet because we gave the IP subnet 0 command. And then Class B, network, node, 255, 255, 255, 255, 255, and we looked at in the last section the private addresses that we can use with these things. You may see the /, and we've done problems with those, the /, how many 1s are in the subnet mask, which is, it's a shortcut way of writing it. I mean, Cisco does this, and then typically you can't, the routers won't accept it. The newer, I think some of the newer routers will accept it. IPv6 is all / because can you imagine writing a subnet mask in 255s or whatever? It wouldn't be 255s because there's more than that for a 128-bit address. So they use the /, they use a slash notation in IPv6. They don't generally use it in IPv4. although you'll see them written that way. How many ones are in the subnet mask? This is just what's the sitter value versus the subnet mask. If you need that table, okay. If you don't need that table, if you can do the math, it's not anything magic. We just add the placeholders up. $25, $26, and this is obviously in the Class C. $27, $28, $29, and $30. 30 is as far as we can go, isn't it? Can we have a 31-bit subnet mask?
Yes.
Can you? Tell me how many addresses you have in a 31-bit subnet mask. None. You do have two, right? You need at least 2 bits. You have 2 addresses. One's a 0 and one's a 1. So one's a network address, one's a broadcast address. You don't have any assignable addresses. You need at least 2 bits. At least 2 bits. This is as far as you're going to go that you're going to have usable hosts. The 30-bit, 2 bits for hosts here, 2, 4. One of them's the all zeros, one of them's the all ones, one of them's the network address, one of them's the broadcast address, not assignable to hosts. So it leaves us 2 assignable addresses. That's typically going to be the subnet mask that you would want to see as you go from router to router, because you're going to maximize the number of networks you have. So you have 1, 2, 3, 4, 5, 6 bits for networks, 2, 4, 8, 16, 32, 64 networks with 2 usable hosts per network with that mask. Class C, first valid host, the subnet. Okay, we'll go just quickly here. The network, all zeros in the host bit. They're showing 0, 0 subnet with all zeros in the host. The first valid host is 1 in the last bit of the host portion. The last usable is all 1s in the host, but a 0 in the last bit. I mean, we can do all sorts of how to get there, but put a 0 in the last bit, but 1's every place else, that's your last usable address. And the last usable address, probably not going to be odd, is it? The only way you can get an odd number is if you have a 1-bit. And if you got to have a 0 in the last bit, then it can never be odd. Just one of the little sanity checks as you go through is this a reasonable way to do it? All 1s in the host bit's going to be the broadcast address. Broadcast, sending traffic to all the machines on that network. Answer to 5 simple questions. Fast method. How many subnets does the chosen mask produce? 2 to the whatever number of bits you're using, 2 to the power, and that goes back to if you write down those 2 to the powers, then you can get those relatively quickly. How many valid hosts per subnet are available? Same thing. How many bits have zeros? How many bits have 1s? Number of subnets, 2 to the number of bits that have 1s, subnetted bits that are added to the classable mask. What are the valid subnets? What's the broadcast address of each subnet? Broadcast address, all 1s in the hosts. What are the valid hosts in each subnet? Add 1 to the network and subtract 1 from the broadcast. That range is your assignable, your valid addresses. How many subnets? We've already done those. 256 subnet mask block size or base number. He is a great fan of memorizing block sizes. I'm not a great fan of memorizing block sizes. If you know how the 1s and the zeros work, it's going to work a lot better for you, because wildcard masks, when we do access control lists, use the 1s and zeros not exactly in the same way the subnet masks do, but if you know how these things work, then it makes writing those much, much easier. And he goes through, I got his video, and he goes through the Class C, but what about the Class Bs then? How many of these things are you going to memorize? If you want to do that, yes, you can set it up to memorize 1 bit this block, so many addresses, so many networks, and on and on. Or you can multiply by 2. That's all you got to do. And I know all of you guys can multiply by 2 because you've gotten through the math class. And that 2 to the power, 2 to whatever power is just multiplying by 2. 2 to the first power, any number to the first power is the number itself. So start with 2, 4, 8, 16, 32, 64, multiply by 2. Once you get above like 40, 96 or things like that, I got to go write down with my stubby pencil on a piece of paper. But you don't get those very often. You may, but you usually don't get. They usually won't give you those. Variable length subnet mask, subnet 64, and this one actually I want to go into is a couple of subnet 32, subnet. Okay, subnet 32, subnet 64, subnet 96. What he didn't tell us was how many of whatever he wanted us to do, did he? And this other one? What this is showing is that the subnets, this subnet 32, which is how many bits in the hosts, 2, 4, 8, 16, 32 would be 5 bits in the host, 3 bits, right? So the 001 would be the 32-bit. The 96-bit, actually he's not doing VLSM. He's doing sitter, isn't he? 32, 64, 96, that's 32 each time. True? This one is going to be a little bit different. 28 provides 14 subnets with 14 hosts. No, I still got the same one. All routers, subnet mask, so all of them are the same size. What we want to get to is how we do these things if we have different numbers in each of the subnets. This is kind of the way he draws it out. Here's the picture I'm trying to get to. What this one says is we're going to have a different number of hosts. Network A, 12 hosts. Again, he goes through the blocks of. If we have 12 hosts, how many bits do we need to have 12 hosts? 2, 4, 8, 16 would be 4 bits, right? Which would leave 4 bits for network. Let's presume that we're working in a class C. So what's going to be the network address? What's going to be the network address if we need 12 hosts? 2, 4, 8. 255.2. No, that's not. That's a subnet mask. What's going to be the network address? You guys are making this really hard, aren't you? 192? Wow. Could be, but no. That's a legal address, but that's not one. How many bits for network if we have 4 bits for hosts? Yeah, and what we got? 1, 2, 4, 8. So what's the first network address? 16. Just like in the diagram here, we go down to 16. And now he says in B we need 20 hosts. How many bits do we have to have for 20 hosts? 5 bits, 2, 4, 8, 16, 32, which leaves us 3 bits for network. So that's going to be what? 128, 64, 32 will be the network address. So we start here, 32, and he's arranged this a little bit differently. I'll give you Cisco's rule in a minute, and that's what works best typically. 32, and he didn't follow Cisco's rules, by the way. 32 to 64, we use this chunk, and if you keep looking at this table, what you do is take the number of hosts and you fit it into the range. What you can't do is overlap the addresses. In other words, we couldn't take these 32 and start them out here with 24 and then have the 16 go to 32. So they have to be in separate areas of the range. What Cisco says to do, and again what he didn't do here, is start with the largest number of hosts that you need, the largest network. And the problem that you're going to have in Packet Tracer does that. Start with the largest number of hosts, assign that one, then go to the next largest and the next largest. We'll do an example here in just in a second. Let me go through the rest of this thing. But this is a visual on how this thing would work. If we go down here 96 to 100, these will be things that will be connecting the routers together. We only need 4 bits, 2 addresses for each of those, or 2 bits, 4 addresses. Same thing here, and again, I want to do an example, and you can look at these things. He's got the summary example. Let's get out of here and let's do our own example. How's that? Well, you can do a Packet Tracer, but we don't need Packet Tracer for that. Do we?
Don't know. Are we far enough?
Are we far enough to do Packet Tracer? Do you need Packet Tracer to calculate how many bits you need for an address? Let's don't even use this. Let's don't even use this. Let's use just a stubby pencil and piece of paper. Huh? Let's say that we have a network and we want 120 hosts on one, and let's say we want 28 on one. I'm going to try to go in order here. I should go in order, right? Sure. Let's say we want 60 on another one, 28 on another one, and then we need 2 and 2. How's that? How's that? We've got a Class C network, 192.168.3.0. How's that? Okay? Not good enough. Don't we have enough hosts? So 192.168.3.0, we can go from 3.0 to 3.255, right? That's the range of addresses. And we will say that we have IP subnet 0 so that we can use the 0 address. If we want to have, and I guess I could bring this, I want to use my spreadsheet. How's that? If I can find my spreadsheet. Just to do the calculations. Yeah, it's in here too, I think.
You were just using it last week.
Yeah. Yeah. Have the spreadsheet up. The first one that we wanted was 120 hosts. How many bits does it take to get 120 hosts? 2, 4, 8, 16, 32, 64, 128 takes 7 bits, right?
Yeah.
7 bits. So 7 bits, that's pretty easy. 7 bits is going to be, I'll get back up here, 2552.255 dot 128, which we couldn't use in the past, but we can now, right? So if we put a 1 in here, and we had a 3 in this one, right? What's going to be our now our network address, and the reason I put that one in, that's as high as we can go. Our network address is going to be .0 because we're going to start with subnet 0 now because we use the IP subnet 0 command. So the network address that we're using here is 192.168.3.0, and we go to 192.168.3. What's the broadcast address of that network? 127. That means that we haven't used 128 through 255, true? We've only used a part of the network. The next one says we need 60 addresses. How many bits to get 60 addresses? 120, let's see, 2, 4, 8, 16, 32, 64, 6 bits, right? 6 bits. What can we start with for our network address for the 6 bits? We can start with 128. So let's go up here and we'll put 6 bits in for this one. And we want our network address to be 128, right? Don't we? Because what did this one end at?
127.
What's the next address? 128. So we can use 128, which is going to be a 1, 0, 0, 0, 0, 0, 0, 0, right? What's going to be our subnet mask? Now we get Andrew with his 192 in here. The subnet masks are going to change because we've broken this thing down. So now in this one, we should be able to use, for the subnet mask, 255.255.255.192. The addresses that we're using are 192.168.3.128 to, how many do we need? How far do we go with this thing? 192.168.3 dot, what's it going to be? What's it going to be? What's going to be the broadcast address of this one? That didn't work out real well, did it? Yeah, it did. 128 to 191. Yeah, it did. 128 to 191. What's going to be the next available network address? 192. How many hosts do we need now? 28. How many bits does it take to get 28 hosts? 32, 5, right? So let's go back here and do our 5 bits. We're going to change it. 5 bits, we'll leave 3 for network. And what's the network address that we're going to start with? Let me take out all these broadcast bits here. 192, which is going to be a 11 here. Is that true? Mm-hmm. 192, and how far do we need to go? So we'll put 1 in here. And that goes to 223. Dot 123, dot 223, right? 223. What's their next network address, actually? I missed it. I have a really big network there, don't I?
Oh, no, I can't see it.
Well, let's see if we can make this bigger. See if we can make this bigger then for you. Huh? Format, font. Should have told me that earlier. Can you see those?
No.
No.
Yeah.
Yes. So for 120, 255, and we go down, this one went down to the next line because it's got word wrap turned on. Let's make this a little bit not quite so big so that we can get it all on one line. Let's try 26. There we go. Can you see that? Possibly. So in this one, we're going to get the subnet mask. What's the subnet mask going to be? 224, right? 255.255.224. What's going to be the address range? 192.168.3, and we know it started with 192, right? Because that was the next available network address. And we go to 223. Dustin already got that one. 192.168.3.223. Now we need 2 host bits. How many are 2 host bits? We need 2 addresses. How many bits to get 2 addresses? 2 bits to get 2 usable addresses. So we will go here. So that gives us a 252 subnet mask. True? 255.255.255.252. And the network address will be 192.168.3.224 because that's the next available. And we're going to go to what's going to be the broadcast. That one's pretty straightforward, isn't it? 11. I don't have enough in here, do I? We started out with, I didn't give us a very good network start, did I? 224 and then a 11. So the broadcast address will be 227. You believe me?
Yeah.
224, 225, 226, 227 is the 4. So 192.168.3.227. What's the next network address? Whoop, 227. So the next network address would be 228, right? And how do I get that? I put a 1 in the 4-bit, now we got a 228. What's the subnet mask going to be? 2 hosts is not going to change. The subnet mask is still going to be 255, 255, 255, 252. So the subnet mask here is going to be 255, 255, 252. And we're going to start out with 192.168.3.228. And we're going to go to 192.168.3. Anybody got that one? 231. And we still have a few addresses left. You'll use the same process. Don't try to do them all at once. Do them all at once, and then you're really going to get confused. But it goes back to write the binary. How many do you need? And in this case, it's going to be hosts. So we got, in this one, we got a 5, 4 ones and a bunch of quarters down here or whatever. When we broke the thing down. We use the same process. Just how many bits are we going to use? And we don't have any overlapping addresses. You can jump around if you do it in an orderly fashion, and if you do the Cisco test, and if they ask you one, you're going to have to go in an orderly fashion. The hint on their subnetting VLSM questions are that just go by the number of bits, the / bits, but they'll have 2 addresses that have overlaps. Those are the ones that you have to discover. They'll have one like, that only 248, 16, 32, 64, 128, that only the / 25 fits, that only the / 26 fits. But they'll get down here, and they may have 2 or 3 of the / 30, and one of them will overlap the other one. Those are the ones that you have to discover. The packet tracer one that you have has the, actually let me take a look at it with you. Go back to Moodle, labs and worksheets. The cheat sheets here. Packet Tracer, if you need it, is there. Right-click and download it. It should be all of these machines. Packet Tracer 5.3.2 is the latest one. It's the safest one to have. If you open one of these Packet Tracer files and you get a blank screen, it means that the Packet Tracer file was made with a later edition, and you need to upgrade your Packet Tracer. 5.3.2, as far as I know, is the latest one. So it is there. If you need to use that, just unzip it to the root of C, and you'll get a Packet Tracer folder. Go to the bin folder, the binary folder, and run the Packet Tracer executable. There are other study materials. Week 1 here, I put a bunch of stuff in. If you want to do subnetting refresher, this is a Cisco subnetting lab you can go through. It takes you step by step through IPv4 subnetting. There are 2 problems there. There is in here a VLSM, a PKA file. You want to open, I hope. Maybe I'm going to open. Okay, Packet Tracer is open. When you look at this problem here, the instructions are in the Packet Tracer. There are 5 pages, go from page to page. It tells you what to do, what to calculate, and the addresses to put on the hosts based on the first address, last address, or first address, second address, those kinds of things. The interfaces on the router, the addresses are already configured. What you got to do is hook up the hosts using the correct cables and put the addresses on the hosts in Packet Tracer after you calculate what they should be. Once that happens, you should be able to ping across the network, because there are only 2 networks that are used here. Router, the interfaces are up, the router knows about them. So you should be able to do those. Once you have completed that, and I put a place for you to upload it in Packet Tracer, upload it in Packet Tracer. Oh, there is one thing that you can do in this one is, as you go through, you can check the results. Overall feedback just says it's incomplete. If you want to see what's being checked, you click on this. If you want to see what you haven't done yet or what you have done according to this lab, you can look at this. Obviously, I haven't done anything on it, so they're all X's. So you can look at the activity, check the activity as you go. Questions about that one? A VLSM, instead of giving you a bunch of VLSM problems, just do this one, get the addresses, put the addresses on. Once you get it to ping across the network, you're in business. The other thing that some people may want that's in this thing framing is a Wireshark. If you want to go back through Wireshark, that's kind of a step-by-step how to use Wireshark in the week 1. I need to clean up the frame examination and the TCP UDP with NetStat. So if you would work on the Packet Tracer problem first, those shouldn't take very long. Once we get them, they're looking at Wireshark again. But looking at the header, you notice we never quit looking at these headers. So take a break, work on the Packet Tracer, and let me see if I can get these cleaned up for you, and I'll have them for you today. As well.